Jupiter hosts the most powerful auroras in the solar system. Unlike Earth's northern lights, which appear only during strong solar activity, Jupiter's auroras glow almost continuously, driven by charged particles interacting with its massive magnetic field. But recently, something unexpected showed up inside them. While studying these auroras using the James Webb Space Telescope, astronomers discovered a strange feature hidden inside an auroral footprint connected to Jupiter's volcanic moon, Io, a region that was not hotter, but colder, and even more unusual, it was significantly denser than everything around it. What makes this even more mysterious is that it appeared only briefly, and then disappeared. A fleeting signal that suggests Jupiter's auroras may be far more dynamic and far less understood than we once believed. So what exactly did JWST detect? And why is this puzzling scientists? Let's take a closer look. This wasn't a random accident. The James Webb Space Telescope was observing Jupiter's northern aurora using its near-infrared spectrograph, focusing on something scientists already knew existed: auroral footprints created by moons like Io and Europa. These footprints are bright regions where powerful electrical currents, generated by the moons, connect directly into Jupiter's atmosphere. Normally, they're exactly what you'd expect: bright, energetic, hot. But this time, JWST didn't just capture an image, it analyzed the light itself. Instead of simply seeing a glowing spot, scientists were able to extract real physical data, like temperature and density, from the aurora. And that's when things stopped making sense. Inside Io's main auroral footprint, they found a compact region that was dramatically colder than everything around it. The surrounding aurora measured about 766 Kelvin. But this region, only around 538 Kelvin. That's not a small difference. That's a completely different physical condition, inside an environment that should be dominated by heat. And it gets even stranger. This cold region wasn't empty, it was denser, about 3 times denser than the surrounding aurora, and in some tiny areas, up to 45 times denser. That's not noise, that's a real structure, something physically distinct, hidden inside one of the most energetic systems in the solar system. But the strangest part, it didn't last, because this cold, dense region may have only existed for minutes. Out of multiple observations, it appeared in just one snapshot, which means scientists may have captured something incredibly rare, a short-lived event forming and fading in real time. And that changes everything, because now we're not looking at a stable feature. We're looking at a dynamic process, something that appears suddenly and vanishes just as quickly. A system that isn't just powerful, but constantly shifting in ways we're only beginning to detect. So how did scientists even know this region was colder? This is where science becomes incredibly powerful. To us, auroras look like glowing curtains of light, but to scientists, that light is information. Inside Jupiter's aurora is a special ion called H3+, a charged form of hydrogen that acts like a thermometer for the planet's upper atmosphere. By analyzing the exact wavelengths of light emitted by this ion, scientists can determine both temperature and density. And this is where the James Webb Space Telescope changes everything. Its instruments don't just take pictures, they break light into detailed spectra, revealing the physical fingerprint of the gas itself. So instead of saying, "This area looks bright," scientists can say, "This region is colder, denser, and physically different." But there's another critical detail. JWST didn't capture just one image, it scanned across Jupiter in multiple exposures. That allowed scientists to compare different moments in time, and that's how they discovered something even more important. If all the data had been averaged together, this cold spot would have completely disappeared, hidden, smoothed out, erased, which means phenomena like this may have been happening for years, and we simply didn't have the tools to see them. Now here's why this matters. Io and Jupiter form one of the most extreme interactions in the solar system. Io is the most volcanically active world we know, constantly releasing material into space. That material becomes ionized, feeding into Jupiter's massive magnetic field and generating powerful electrical currents. Those currents crash into Jupiter's atmosphere, creating the glowing auroral footprints we see. For a long time, the assumption was simple. More energy means higher temperatures. But this discovery breaks that idea, because somehow, in the middle of all that energy, a colder, denser structure formed, which suggests something deeper is happening. Maybe energy is being redistributed in ways we don't fully understand. Maybe we're briefly seeing different layers of Jupiter's atmosphere. Or maybe there are fast, short-lived processes happening that we've never been able to observe before. And this is where the story expands beyond Jupiter, because if something this unusual can happen here, it might be happening elsewhere too. Other giant planets, other moon systems, even distant planetary systems far beyond our own. This discovery isn't just about a cold spot, it's about realizing that these massive environments may be far more complex and far more dynamic than we thought, and the timing couldn't be better. NASA's Juno mission is still studying Jupiter up close. Europa Clipper is on its way. And ESA's JWST mission will soon explore the system in even greater detail. The James Webb Space Telescope revealed the mystery from afar. Now, these missions may help us understand what's really causing it. We thought we understood Jupiter, a world defined by extreme energy, heat, and constant motion. But this discovery revealed something unexpected. A cold, dense structure hiding inside one of the most powerful auroras in the solar system. And if we miss something like this, on one of the most studied planets we have, what else is happening out there that we still haven't seen? Thank you for watching, and see you next time.